right, how's it going? Pretty good. Running on like 4 hours of sleep, so I'm in a good mood. Good stuff. What is sleep? Yeah. All right, questions?
So I have on my ODP program, all of, I guess the grading is like 10 out of 10 except for 1.
Yeah.
Figuring out what I'm going to do.
Okay. So what test cases did you try? So did you test your program before you said assess?
Yes.
Okay, so how did you test it?
So I did like with 2 arguments. And
Okay.
then a negative number. And then,
So what were your 2 arguments? 2 numbers?
yeah.
Okay. All right. And then you did a negative number?
Mm-hmm.
All right. What else?
And then I tried it with no argument.
Okay.
And then I tried it with a letter. Or a word. So I tried it with 2 words. And then I tried a decimal number. That worked.
Okay. Oh, I guess I see. And it passed all of those?
Yes.
Okay. Do you care if I put your code up on the board? Is that okay? I can do it with the screen off if you want. Let me turn the screen on. So it had a problem on test H. Let me look at your code. And you tested it with no arguments.
Yeah.
And what did it do? So the write-up asks you to check exactly those conditions you just named, right? Make sure you have exactly 1 argument. If you have too many or too few, print out ERR. If there is an argument but it's not a valid number, print out INV. If there's an argument that is valid but it's negative, print out NEG. Otherwise, take the square root, print out the square root. And I think your code, if you run it with no arguments, it's going to segfault.
Yeah.
Okay. So, and segfaults definitely will assess poorly. So let's look at code for this. All right, so if there's not exactly 1 argument on the command line, print out error. So how did I do that? Check argc, right? If argc is 2, you have one argument. If you have one argument, argc is 2. They're the same condition. So if argc is not 2, I'm just going to print the error message and I'm going to say, get out of here. Okay, just do a return. Otherwise, we have one argument. See if it's a valid double. So try scanning it using a %lf. What do we scan? argv bracket 1. That's the first argument. Check the return value from scanf. If it's exactly equal to 1, you converted a double. If it's not equal to 1, something went wrong. That's not a valid number. Print out invalid. And then do your return 0. Otherwise, scanf succeeded, and our double should be stored in this variable x. So now, check to see if it's negative. Right? And if it is, print out negative and return. Otherwise, we've passed all those tests. Take the square root, print out the square root, and you're done. Okay, so here's what can happen. So let me go ahead and run this. And you have to use -lm when you link to pull in the math library. So ODP 409 without any arguments gives me an error. With 2 arguments, it gives me an error. With 3 arguments, it gives me an error. With a single argument, it prints out the square root. If that single argument is a word, it gives me an invalid. If it's 2 words, it gives me an invalid, or an error, right? Because not one argument. And if it's a negative number, it gives me a negative.
I ran it with number 4 and then letters after it, and it gives you a valid answer of 2. But how would you check to get rid of an answer that had letters?
That's a little harder to do. And so my rule is usually if scanf sees this as a valid double, take it as a valid double. And I'm usually not requiring you to be more rigid than scanf will be. Okay, so we would look at this and we'd say, yeah, your input ends at the 25 and the rest is just extra input. If you want to do that, it gets a little complicated. So here's something I saw in a lot of people's code. Something like this. Right, same set of code, just a slightly different order. Still works the way you'd expect. Right, but with no arguments, we get our dreaded seg fault. And why is it seg faulting? It's seg faulting right here because we're asking it to take element 1 of the argv array and try to convert it to a double. And if you run your command with no arguments, what is argv bracket 1? It's undefined. Because with no arguments, argc is equal to 1, argv bracket 0 is the name of the program. argv bracket 1, 2, 3, 4, 5, undefined. If argc is 2, element 0 is the program name, element 1 is the command line argument, 2, 3, 4, 5, 6, undefined. So you're allowed to access argv 0, argv 1, all the way up to argc minus 1. And this gives you a total of argc elements in your array. But if argc equals 1, that means this is the only thing in the argv array. And as soon as you try to do anything with this, you're probably going to seg fault. Right? And definitely if you try to scanf argv1, it's going to seg fault.
I have one quick question about this program. So I ended up doing this way, which is just ifs and else and all that, which is just returning. But if you wanted to use exit and include the library that includes exit, is it like with math where you have to include a switch when you compile it, or no?
Honestly, I've never used exit in a C program. And I don't know how assess will deal with it. He doesn't like it?
No.
Yeah.
So just use return if you want to leave the function.
So it exits with a status 8 bits, returns to the parent. Yeah, so you don't have to put in a -lm, but but you have to include standard lib.
Okay,
But it should just link with GCC.
oh.
But yeah, beware if you try to do that with assess. All right, so no ODP for tomorrow. I will post an ODP tomorrow morning, which will be due Friday morning. And there's no school on Friday, remember. So that's the faculty work day, so I get to work that day. All right, so any questions on the ODP 409? All right. Oh, good, my laptop died. All right, I posted a scary announcement on Canvas this morning about lab groups. So the lab kits are in the cabinet in the back of the collaboratorium. If you open the right door, there's a sign-up sheet to say which group you belong to. If you already put your name on that list as of this morning, don't have to do anything. You can sleep for 2 minutes, okay, while I talk about this. If your name is not on that list, okay, you're going to get a 0 on the lab unless you take action. Okay, so here's what you got to do. Figure out what group you're going to join, or maybe you already know you're in a group and you just haven't put your name on the list. So figure out what group you're in, put your name on that sign-up sheet, and please put your full name on there. If you've already put it on there, you're fine, but if you're putting your name on there, first name, last name from Canvas, okay, so that I can match you to your Canvas entry. And then send me an email, okay, with the subject CSE 224 lab groups and tell me what group you're in. Because I need to add you to that group number on Canvas. It's supposed to let you do that yourself, and it's not letting you because I don't know how to do it apparently. So I'm putting people in these groups based on their sign up. But if all you do is sign up the list, I'm not going to know who's new and who's not new, and I'm going to go back there 20 times and all. So you got to send me an email, okay? And I'm not going to put you into a lab group until I get that email from you. And if you're not in a lab group by the time your lab is submitted and I grade it, then you're not going to be associated with the report and you're going to get a 0. So just pick a group, sign up on the paper, send me an email. All right, and do that by Friday at noon, okay, because people start submitting at some point. Does that make sense? And only like 20 people have signed up on that sheet so far, so you're not alone if you didn't. You're in the majority. All right. So let's talk some more Linux. All right, so I'm in a directory here, and we talked about directories yesterday, right? Making directories and moving around, and PWD shows you your directory and all of that, right? So I'm sitting in my directory and I can say ls and I can see a list of files that are in this directory. And we know we can put switches on ls and get more information about these files, such as the permissions, and we talked about permissions already, true? Okay, read, write, execute for the owner, the group, and the world. We can see who owns the file, we can see the size, when it was created, mostly October 4th or 5th, and the name of the file. So you copy a file with a cp command, right? So cp says missing file operand, try cp -- help. Okay, so you can do that, or you can say man cp, but cp basically takes the source file and the file that you want to copy it to. Most Unix commands, the output argument is the last one. There's a few exceptions to that, but it gets you like 95% correctness. So if you're saying copy, should I put the new file first or last? It goes last. Okay, but check the man pages or something. So this will copy this file up here called file to a file called copy of file. And now if I say ls-l, I've got a copy of my file. And it's the same size as file, it's 24 bytes, but it was created October 10th at 11:16. That was just now, right? Whereas file was created 6 days ago towards the end of class, at 11:48. So cat shows us the contents of a file, so that's what's in file. This is what's in copy of file. So it's just a copy, right? Now if I want to remove a file, I can just say rm and the file name, and that gets rid of the file. So now my copy is gone. And obviously if you try to remove a file that's not there, it's going to give you an error message. If you want to rename a file, you kind of got two ways you can do it. I could copy file to a new file and then delete file, and I'd have a new copy of it with a new name. But that's a lot of work. An easier way is just to use move, which is basically rename. So if I move file to copy of file, and I do an ls-l, file is gone, right? And copy of file appears. But notice copy of file was created October 4th, right? It's the same file that I had before that was called file. It's just got a different name. So moving is fundamentally different from copying and deleting the old, right? It really just sort of changes that rightmost column. Now if I throw a -I switch in the beginning of, or in my ls switches, it shows me these numbers over here on the left. These are called inode numbers. This is how the operating system actually sees these files. The operating system doesn't think copy of file, it thinks file number 4197714. Right? That's how Linux sees that particular file. HaHa2 it sees as 4197171. So if I say move copy of file to file, and I do another ls, copy of file is still, file is still 4197714. Right? Same as copy of file was. So move is really just changing the human readable name of that file. It's not changing where it's stored on disk. It's not changing how the operating system sees it. It's just kind of a rename. But if I copy file to a new file, right? File is still 7714, but my copy has a new inode number. It's a totally new file. And again, created October 10th. Does that make sense? Okay. So these permission bits in the beginning, remember the basic setup is read, write, execute. And this is for owner and group and world. So this is the person who owns the file. Those were all Nick. This is the group of people associated with that file, and that's again Nick, and then world is everybody else. And when we say change mode, and we put in some magic 3-digit octal number, you can write each of those in binary. There's 7, there's 7, there's 5, there's 5. That corresponds to read access, write access, execute access, read access, no write access, execute, read, no write, execute. So if I change mode to 755, I should see that bit mask. So let's say change mode 755 file, and then do an ls-l on file, and there's your bit mask. So read execute for everybody, and also write access for the owner. So if I want other people to have no access, but I want full access, so read, write, execute, no access, no access. So that's a 111.000.000, and I say change mode 700. All right, so now I've got full access. Nobody else has any ability to access it. Now let's say this is a really special file. and I want to be able to read this file because it's got special stuff in it, but I don't want to accidentally modify it or delete it. So I want to give myself read access, but no write or execute. And I'm going to do that for everybody in the world. So what's my change mode command going to look like here? Yeah, so 100 on each of these. This is the octal code for 4, 4, 4. So there's file, and it's got read access only. So now if I try to remove file, it'll say it's write protected. It'll let me do it because it knows I'm the owner, and it knows I can change the permissions and delete it, so it'll offer to do that for me. If I try to edit it, it'll tell me it's a read-only file. And if I try to write it from here, it tells me it's read-only. And sometimes you can override it, but in this case, you can't. But if you really want to edit it, you can change the permissions to whatever is appropriate. And now I've got full read, write, execute access. So if I set it to 0, nobody's got any access of any type to this file. And now if I try to cat it, it says permission denied. If I try to VI it, it says permission denied. If I try to remove it, it says protected file, and so on. But I can put a force switch on my RM command, rm-force, and it'll completely ignore any permission issues. Now if I try to remove a file that I don't own, it'll still give me permission denied, right? But it basically says if there's a way that you can remove this file, I'm going to go ahead and remove it for you. So here's a new project directory, and it's got a couple of files in it. And if I try to remove new project, it'll say you can't remove that, it's a directory. So RM is really intended for files, and rmdir is intended for directories. But if the directory is not empty, rmdir will refuse to remove it because it figures you've got stuff in there for a reason. But there's a switch you can use on RM, which is -R, which says remove recursively, which is a fancy way of saying remove everything from this point on down. If this is a directory, remove everything in that directory. If there's subdirectories in there, remove everything in those subdirectories and keep going until there's nothing left, right? And if you say -RF, it'll ignore permission problems. So I can say rm-rf new project, and now that whole directory structure is gone. Okay, here's what you don't want to do. Be really careful about typing that in. Because whatever directory you're sitting in, this is a wildcard, we'll talk about this later. This is a wildcard, it matches every file in your directory. This will remove every file in your current directory and every file in every subdirectory underneath your current directory. If you do this from your login directory, you wipe out all your files. No questions asked, right? It won't say, are you sure you want to do this? It's just gone, right? So I did this once as a super user from the / account on a machine. And after about 3 or 4 seconds, I realized what I'd done, and I hit Control-C really fast, and it managed to wipe out about 30 files in the process. But they were all system files. So I had to go tell someone, get a backup tape, restore the files. Everybody does this eventually, right? Hopefully not from the root account, from the root directory, but inevitably you do this from the wrong directory in your stuff and you lose things, and hopefully you've got backups, right? I won't admit how many times I've done this and did not have backups, but it's bigger than 1 or 2. So don't do like I do. All right, and all of these things, right, you can do man rm and see all the information about rm. There's the force option, ignore non-existent files and arguments, never prompt, right? Here's the -R option, recursive, remove directories and their contents recursively. And there's a zillion other options. You can do a -V and actually watch the carnage while it's taking place. So you can see everything that's being done. So I can RFV 224, and there's everything that got removed. And so my beautiful 224 directory we've been using is gone. But I can make it by saying make dir 224. I can go into there, but of course it's empty. All right. So here's my beautiful C program that I'm writing, and while I'm in the process of writing this, something happens, your network connection goes away, and your dog comes in and clears your screen. And you come back later that day, and you try to VI your code, and you get this famous screen, right? So raise your hand if you've seen this, right? So what is this about? Let's deal with this once and for all. This is telling you that basically it thinks somebody else might be editing this file at the same time that you're about to try editing it. And that's not something you would want to have happen. If you're editing a file and you're in VI making changes, saving changes, and I come along and I start editing that same file, what can happen? You write a bunch of lines of code and you put them into your version of the file, and I make one change and I say :W to write my file out, and all those changes that you made on disk are gone now because I just replaced them with my version, which didn't have your changes in it, right? So your changes start conflicting with one another, and it's a really bad idea. So you really don't want two people editing the file at the same time. So VI, when you start editing a file, in this case mycode.c, it creates a file called .mycode.c.swap. And it's a flag. It's just a file it puts on the disk to say, hey, this file's being edited. So that if someone else comes along and tries to VI, it says, wait a minute, somebody else is probably editing this. But what happens is if you start editing a file, it creates this swap file, right, this flag, and then your network connection goes away. Next time you log in, that swap file is still there. And you try to edit your file and it says, wait a minute, there's a swap file here, somebody else might be editing this. Well, there isn't, okay? You were editing it and your edit session got killed because the network went away. But it doesn't know that that's what's going on. So it's telling you, I found a swap file, this is the file name, right? This is when that swap file was created, all this stuff. So you got some choices here. So first thing I would do is :Q exclamation mark, get out of there, okay? :Q quits, :Q exclamation mark quits, even if you've made changes. So don't change anything, right? And go ahead and cat your code. See how it looks. And if it looks like the code that you were working on last time, that's good. But if you typed in a bunch of changes and those changes didn't get saved to disk and you don't see those changes here, you may have lost those changes. But VI will write information into that swap file to try to help you recover from a broken connection. So you can say VI-R mycode.c, and if there's changes in that swap file, it'll recover those. Now, I don't have any changes in there, right? Recovery complete, buffer content equals file contents, and hopefully whatever you did and didn't save to disk will show up in here. So you save those, but that swap file is still there. So if I try to VI again, it's going to give me the same warning every single time. So the way you make that warning go away is just remove mycode.c.swap. But don't just remove it when you see it there, unless you're positive that the mycode.c is the version that you're happy with. Because if you made changes and didn't save it, you can recover them, but once you delete that swap file, you can't make any more, you can't recover, right? So if you're missing code, you'll be missing code. But once that swap file is gone, you can VI and you don't get those errors. Does that make sense? All right, so let's talk about Executing commands. So you say ls and it shows you what's in your current directory. And it does that because when I say ls, somehow it's running this command called /bin/ls. But if I write a program script named ls, and I make it executable, and I say ls, it runs my script now. My ls command doesn't work anymore. Now if I'm sitting in a different directory and I say ls, ls works great. And I can say ls, show me what's in the 224 directory, and I can see what's in there, and there's my script called ls, and my code. And I can say ls-l. But if I'm in this 224 directory and I say ls, it seems to execute my script instead of /bin/ls. So I can say which ls, and it tells me I'm about to execute ./ls if you say ls. Dot is, what does dot mean? Current directory. So in my current directory, there's a file called ls. That's what it's going to execute. But if I say where is ls, it says, oh, there's also an ls under /bin. And there's one under homenick 224 ls. And there's the manual page. So I could say /bin/ls and get the actual ls command. And I can put switches on that and so on and so forth. So how does it know what to do when I type ls? So I'm going to use this command printenv. And this is going to show me a bunch of variables that have been already set up for me. So for example, there's a variable called shell, and it's equal to /bin/bash. There's a variable called user, and it's equal to nick. And I never said user equals nick, right? So bash itself creates some variables. Just like if you say x equals hello, I can say show me the value of $x, and it'll print out hello. Well, I can echo $user, and it shows me my username, which can be handy. So there's a particular variable called $path, and the path variable is a list of directories separated by colons. And these are the directories where if you say blah, it will search each of these directories for an executable file named blah. And the first directory that it finds blah in, that's the version of blah that will get executed. So your path by default on here is set up to start with a directory dot. That's your current directory. So if I say ls and there's an ls in my current directory, that's what gets executed. This is why you don't have to say ./a.out. Because if you say a.out, first thing it does is search for a ./a.out. And then it'll search for user local sbin a.out, user local bin a.out, and so on. So when I say ls, it checks all these directories, and eventually it'll search /bin, and there is an ls in /bin. That's usually the one that executes. But if I have one in my current directory, that runs. Now if it goes through all of these directories and it gets to the very end and it hasn't found a file with a name that you typed in, then it'll say no such command. So you type gibberish and command not found. And there's a bunch of variables that that you can set up that do different things. So another one is PS1. So PS1 I have set up to this funny thing, bracket, backslash, exclamation mark, bracket. But if I set PS1 equal to hello, that's my prompt. Okay, that's what bash says when it wants me to type something. It echoes whatever the value of this variable PS1 is. So I might make it something a little more useful like that. All right, so you can set your prompt to whatever you like. this backslash exclamation mark says use whatever the current command number is. So it starts counting from 2000 for me. And if I say history, it'll show me my last however many billion commands with this number in front of it. And that number just keeps growing and growing. So that's kind of what I set mine to. But you can set it to whatever you like. Yeah?
Is there a way to change what the A.out automatically outputs to?
Yes and no. So I don't know if there's a setting. You could check the manual page for GCC, which is pretty big. There may be an environment variable, something you can set up that'll affect the default output. But the other option is to make your own version of GCC, right? So, let me do this and then we'll see what it does. I don't know if this will work. We'll try it. All right, so I got my test.c, GCC test.c, and it made my executable, ha ha ha. So how did that happen? Because GCC is the name of a script that we just wrote, and it basically executes the actual C compiler, which is user bin GCC. $* says, give me all the command line arguments to this script, $1, $2, $3, and so on, followed by, separated by spaces. And then I had a command which says rename A.out to ha ha ha. So now I've got my own little GCC command that calls my output ha ha instead of A.out. So you can do things like this like all day long, right? You can write scripts, and we'll talk about aliases, which is a way to change what a command does. So you can have one command like GCC point to a different command like /home/nic/224/GCC. So yeah, there's may not be a direct way to do it, but there's lots of ways you can spin this by hand. And that's really where we're moving this week, and part of next week is sort of figuring out how we can do things to customize our Unix setup for us. All right, so you can change the path, right? So in your home directory, there's a file called .bashrc, right? So it's a hidden file. You don't normally see it unless you say ls-a. But .bashrc is a file that's executed every time you start bash. And you can put whatever you like in here. So my bashrc has a section that says ps1 equals \, exclamation mark, right? That's why my prompt comes out the way it does. I have a command called record, which runs a command called Kazam, which is my screen recorder. Well, now I remember Kazam, so I just type Kazam. But when I first did this, I couldn't remember Kazam, so I could type record, and it would mean Kazam. And so on and so forth. If I'm the root user, I set my prompt to a number sign, so that I know I'm root and I don't say rm-rf*. And you can put whatever you want in here, right? It's totally up to you. So you can customize the environment. And part of what you want to do through this course, right, but in general, is sort of tailor your environment to what makes the most sense for you, right? Humans are a very successful species. We're successful because we're good at making habits. Right? It's one of our great strengths. We form habits very quickly, and we get very efficient at things that we do out of habit. Not to pick on Microsoft, but if your toolbar changes every 6 months, you're not going to be as efficient, right? You're going to have to take time and figure out, how do I create a new mail message in Outlook today? Because I can't do what I've done every day for the past 6 months, right? So Unix in particular, right, you can totally tailor this to your liking. You can call your commands whatever you want. You don't like ls, you can call it something different. And you can put all those customizations in something like .bashrc, and you can take that bashrc and copy it over to another Unix system, and that other Unix system will look like what you're used to, right? So my version of VI looks the same as every version of VI I've ever used, right? As far as color coding, does it put line numbers in the beginning, and so on and so forth. I've got my own script that sets that up the way I'm used to. And that's something you should feel free and entitled to do, right? It's your environment. It's your toolkit, right? Set it up the way you like. Find a way that you like. That's experimenting, you know, hey, I want to try some color coding. I want to do syntax highlighting. I want to do this or that, right? And once you find these things, right, you can make these sort of how things come up by default for you. And the end result is you get really, really efficient at working in this particular environment. And you're going to be in this environment all year, right? You're going to be in this environment probably at a transfer university, definitely if you're WSUV. And so make it comfortable. Make it whatever is efficient for you. That's going to be your best bet. All right, have we talked about PS? So PS is a way to see what processes are running. And if I type PS, it shows me I have two processes. One is called bash, we know about that. The other is called PS. Why do I have a PS process? Because I said PS enter. And to execute that command, the system created a process, right? And there's this process ID in the beginning. 25777 is the process ID for my bash session. 26799 was my PS command. If I say PS again, my bash session is still 25777. That hasn't changed, but my PS is a different process ID. Why? Because it's a different PS command. Every command you execute becomes a new process, gets a process ID, runs, eventually exits. So switch over to the server if we have network. Stop spinning.
Yeah, I've been trying to connect for the past 10 minutes. It's down or something.
Yeah, then it's come down.
Yeah, I can't even.
Access.
You can't get to web pages or anything?
Can't even connect to the network.
If I find out who you can complain to, are people willing to complain? Okay.
I've already been complaining to the
Good, good. Yeah, so right, if we can find the right person to contact, I think if they start hearing from students, it's going to help make the case. So I'll see if I can find out like what the proper channel is. All right, well, we'll just play local for now. So I can say PS-ELF and see every process that's running on this system. So -E says everything, L is long, I forget what F is. But we're just looking at my own Linux system right now, but this is the set of all processes running. Now, if you do this on the Unix server, right, engrcs.com, you'll see every process that everybody is using. If somebody else is logged in and they're doing VI, you'll see their username and you'll see the command VI, whatever file they're VIing, right? So there's not a whole lot of privacy in some sense, right? Processes are totally available for everybody to look at. So we did this in the prior section, and we were on the server, and there were some people playing games, and there were some people editing code and stuff like that. And you can just use this command, right, PS-ELF, and see that. So on my system, right, I'm the only person logged in other than processes being run by root, so all this stuff is mine. But you know, I've got Google running in the background, so there's Google Chrome, and there's my PS-ELF command sitting here at the bottom. And so you can sort of look at the system that way. And you can kill processes. So I can say kill, and if you say kill-9, it means I really want this to get killed. Because kill doesn't actually kill a process, it sends a signal to a process. And if you just say kill, it sends a default signal, which doesn't say go kill yourself. It says, you're being signaled with a kill command, right? But you can say kill dash and put in a number of a signal, and it actually sends that signal. And 9 is the absolute, terminate, right? Don't do any process cleanup or anything like that. Don't check your flags to say if you should be able to be terminated. Just terminate. So if I kill dash 9, 25777, which is my bash session, right? Tells me bash crashed. That's in red. It's a little hard to see, but I just killed my shell. And I'm kind of done now. So I can close that and come back. And I got a new bash session now, and its ID is 26927. So if you do this on a 64-bit system, you get these big long, it's a 64-bit, I don't know what I'm saying. If you do this on some systems, you get this big long 64-bit process ID, 32-bit on here. All right, so here's my PS command, 26944. Its parent's process is 26927. That's bash. Bash's parent is 26924, and that's a process called console. That's how I started this whole thing happening. And that thing's parent is process 912. And process 912 is a process called KDE init, and its parent is process ID 1, and process ID 1 is a process called init. And when you boot up a Linux system, the first process that gets created is process ID 1, and that's init. And pretty much every other process is created by init. And you can take anything that's happening on the system and trace who its parent is and who its parent is and so on, and you'll end up back usually with init. So towards the end of this course, we'll talk about how this works in C. We'll look at the actual C code that you can do to create a process, to control what a process is doing. And because all this stuff is just C, right? Linux is written in C. There's a little bit of assembly language sometimes for device drivers, but it's really just a big C program. You can download the source code and look at it, and you can see what happens when your system boots. What does init do? What does bash do? Right? It's just big C programs. It's nothing that you couldn't write by the time you're done with this course. All right, so I'll leave off there for now. So